It's a moonscape up here most of the time. There's ice changing and the cold and the occasional polar bear. It's a unique experience. I feel very privileged to be up here.
Come up here and you ride on an icebreaker for the first time, and once you get into the ice, you're just hearing sounds and the ship just moving in ways that just don't seem natural. The first time going to the side of the rail and looking at all the ice as it was getting turned up and just seeing, 1 meter, 2 meter thick, crystal blue, pristine looking chunks of ice and just thinking how beautiful it was.
The Arctic had been thought that it was sort of a stable environment, but now we know that the Arctic could be the canary in the coal mine of a warming planet. Changes might happen here first. Changes are happening, and it's important to try to understand what's going on, not just short term, but long term. Beaufort Gyre, it's the way that the surface waters in this region north of Alaska rotate. It's driven by the Beaufort high pressure system which sits over this area. During these periods of anticyclonic circulation, which we're in now, it accumulates fresh water. And then during cyclonic regimes, the fresh water could be released from the Beaufort area, drift across the Arctic, exit Fram Strait east of Greenland, and the fresh water can have an effect on the areas where deep water of the ocean is produced. Deep water is basically the beginning of the thermohaline circulation of the planet. The end of that circulation is the Gulf Stream that flows and keeps the climate of Europe much warmer than it would be if it didn't exist. And if you shut off the thermohaline circulation, that could have implications for the climate of the whole planet.
This program combines two aspects. One is Woods Hole has been overseeing the mooring and buoy work. So stationary, like 3 locations of putting in equipment that lasts for the year, making measurements daily, but in those single locations. And then the complementary work that we're doing where we have come out with the CTD rosette. CTD stands for conductivity, temperature, and depth. And the conductivity gives us our salinity. Those physical properties of the seawater can tell us so much about where the water has come from and how the water moves. It gives us the weather of the ocean. We have a grid of CTD stations. I think it's around 40 or so stations across the Beaufort Gyre, but only at this one time per year. So we're getting a nice spatial coverage to say, well, this snapshot in time, this is what the picture looks like. This rosette combines electronic real-time measurement as it's going from the surface down to the ocean floor, which is 4,000 meters. Then we have 24 Niskin bottles attached, which we're able to close at predetermined depths. And from them we can take water samples and then actually run the chemistry on that water sample.
In order to do our freshwater studies, the centerpiece of our field data is the moorings. We plant these bottom moorings in every year in order to get an idea of the seasonal cycle. The centerpiece of the moorings are the MMPs, or McLean Moored Profilers, which climb up and down the wire between about 40 and 2,000 meters, and they're measuring conductivity, temperature, and depth, so that we can actually understand the physical composition of the ocean, see how it's changing over the course of a year. We've initially had 3 moorings in, one at what was the historical Beaufort Gyre Center, one that was south of it, and one that was east of it. Once we determined that the lens had moved to the southeast, we decided we needed a 4th mooring to go there, where the center of action was. over the last 10 years, basically had 3 moorings, A, B, and D. Every year we go out, cover the moorings, we bring all the instrument on board, we change batteries, we replace instruments as necessary, we dump all the data, and then we put them in for another year. And hopefully we'll do it again. We'll turn them over and keep them going, because the most important thing is to get a long-term time series to study the climate.
The Coast Guard's role in this particular science mission, to take the scientists to these remote stations in such harsh condition. I mean, not every ship can come up here and do this. If you're down south, there's a number of ships that can carry out this work, but in the high Arctic, heavy ice conditions, you need a heavy icebreaker. We actively assist the scientists by providing a support staff. If they're working moorings, then it's, they will have a few knowledgeable people doing their work, and we will assist with recovering the moorings, deploying the moorings, and making sure everything is done safely, I'm enjoying the science mission. It's one of my favorite ones. I've been doing science for approximately 40 years, so I'm familiar with most of the work they do, and I can see the changes over the years. I came here 38 years ago in a similar situation we're in now. And there was communities here and leads of water we couldn't even get the ship into. It was all, ice was too heavy. And now some places are open water. It's a lot easier going. So I've seen firsthand changes over a 36-year period.
We spent a lot of money and a lot of time and a lot of effort to acquire this data set to document the climate during this period of time for the 2000s and the 2010s. To me, it's important to make sure that we have a full and complete package description of this era in the Arctic that we can share with future generations that are going to have even more sophisticated instrumentation, and they're going to look back and say, well, what was it like back then? And hopefully this data will be very useful to them.
I come from a line of fishing folk. I was raised around the ocean. It's always been a very important part of my life. It's one of my happy places, being near the ocean. I've always lived near it. I would hate to think that we do anything to this part of our planet that makes it an irreversible kind of damage. I would hate that. That would be a horrible thing.